Okay, so the next type of question we're going to look at involves situations like this. So when I look at this, I'm immediately thinking of having base numbers of 5. I know 25 is 5 squared, so as soon as I see I can get two things in base 5, I'm thinking I can get this one in base 5 as well. So let's rewrite it in base 5. So I have, oh, hang on, draw. I should be getting used to that by now. So let's go 5 to the power of x times. Now let's change that 25 to 5 squared. I'm just going to put in brackets in a minute, and the power on that 25, on this 25, is 2x minus 3 equals, now I've got to figure out what 625 is, so let's just do that. So 5 times 5 gives me 25, times another 5 gives me 125, times another 5, that gives me 625. So I'm really looking at 5 to the power of 4. So I'm going to pop that in here, 5 to the power of 4. Now that everything has the same base, I can go ahead and group things together using my index laws. I know when I multiply things of the same base, I can add, but I also know when I've got an index outside a bracket, I can multiply those two things in together. So I'm going to do that first. So 5 to the x times, this will become 5 to the 2 times 2x minus 3. So I'm just multiplying that index with that index. That's one of our index laws. Still equals 5 to the power of 4. Let's multiply that out. I'm just going to do one step at a time. So 5 to the x times 5, multiplying that through, so that's going to be 4x, and then minus 6, and that's all going to equal 5 to the 4. And now I'm at my index law where I can add my indices, because I know that when I'm multiplying with the same bases, I add. So that's going to become 5 to the x plus 4x minus 6. That's still going to equal 5 to the 4. So that leaves me with 5 to the 5x minus 6 equals 5 to the 4. Because I have same bases, I can put these indices equal to each other. So let's do that. 5x minus 6 equals 4. So I'm going to get that 6 by itself, so I'm going to, the 5x by itself, so I'll add 6, whatever I do to one side, do the other, so 5x equals 10, so x, therefore, equals 2. And then there's my answer. The next type of question is a little bit trickier. And so let's spend a bit of time thinking this one through. So here we've got a situation where we've got one bracket times another bracket and it equals 0. So when you look at this one, there are two ways for me to get this to equal 0. I can have the first bracket equal 0, so 2x minus 16 can equal 0, or I can have 2 to the power of x plus 4 equaling 0. They are my only two options. So let's have a look at the first option. How does that work? So let's move the 16 onto the other side. So we get 2 to the x equals 16. And I know that 16 can be written as a base 2, so I'm going to write that. So 2 to the x is going to equal 2 to the 4. So therefore, a solution to make this equal 0 would be when x equals 4. Now if I substitute that back up in here, when this goes to a 4, that means this is 16 minus 16. That whole bracket means it's 0, and 0 times anything does in fact give me 0. Let's do the same thing over this side. So I'm going to get 2 to the x by itself. I'm going to take away 4, so it'll be 2 to the x equals negative 4. And then this is a bit of a red flag. There is no way for me to raise 2 to a power, positive or negative, to give me a negative answer. So there is no solution here. Okay, and if you want a little bit more proof, I'll just do a couple for you. If I do 2 to the power of 3, for instance, that's 8. If I do 2 to the power of 1, that's 2. If I do 2 to the 0, that's 1. And then you feel like it's going to go negative, but it just won't. When you go 2 to the negative 1, remember that's a fraction, so my answer is actually a half. So there is no way for me to get a negative answer here. So therefore, for this particular part, there is no solution. So the only solution for this is what we came up with over here, x equals 4.